Evening, sir.
All right. Good evening, Jamie. Good evening. How are you doing?
I'm all right.
All right. Good to hear. How did your SBA go yesterday?
Oh, it was good.
All right. So you got to put together the graph and submit everything?
One thing on the graph though, I didn't get to put in the best fit line. You can, well, I'm not sure how to put in the equation in Excel.
All right. All right. So let's see if we can look at that. So before we start, let me open Excel, see if there's a way to put in the best fit. Let me see. I'm just going to open my Excel and see if we can do that. All right. How can we insert a best fit? Okay. Oh, did you go to scatter plot when you were putting in the points in Excel?
Yes, sir.
All right, I think there should be an option. Let me see. Let me share what my all right, I think there should be a scatter plot. Insert. All right, which one is scatter again? Insert this. All right, here it is. Insert scatter. We'd have to have the data. All right, so nothing is going to be on my chart because I don't have any data. So after insert scatter, I think there should be an option to give a line of best fit. Add, remove, or change element. Let me see if this allows us to add. All right, no worries about it. We'll come back to this. All right, so you told your teacher now that you weren't able to do the best fit?
Yeah, she said the rest of it is good though.
Okay, all right. So what I'll do then is I'll look it up how to create the best. Well, when I say look it up, I'm gonna speak to my IT. I'm gonna go by the IT department tomorrow and let them show me. All right, because they know how to navigate all of that crazy stuff. All right, so tomorrow I'll get back to you with how we can do that. All right.
Um,
All right, no point in trying to figure it out here. So yesterday, Jamie, we would have been doing now, of course, scatter plots and finding the line of best fit. So we're able to make predictions about two variables in relation to each other. Now, today we're going to be doing the same thing, but now we're going to be doing it more suited to the exam. So in the exam, of course, these questions are only going to be worth 3 or 4 marks typically. Maybe a 4-mark question to find R or a 5-mark question. Maybe a 3 marks question to find expected value like this. And anthropologist finds the length of a female to be 58 centimeters. How tall was the person? these things only going to work like 4 or 5 marks. So of course, those tedious calculations, we only do that when we're carrying it out from hand, right? After we did the experiment, we use those formulas. That's the formula that we use for research purpose. Now for an exam, this is the formula that we're going to be using. So let me go over to the PowerPoint. This is the one that is going to be on the formula sheet. All right. So let me go down. Here it is. All right. So this is the formula that we're going to be using for R, Jamie. The formula that we're going to be using for R is n times the sum of x times y minus the sum of x times the sum of y divided by the square root of n times the sum of x squared minus, in bracket, the sum of x all square, close that bracket, multiplied by n times the sum of y squared minus, in bracket, the sum of y all square, close that bracket, all square rooted. Let me just write it out so you can see it a little better, because I know this right here may not, maybe it's not 100%, but let me write it out a little better. All right, so this was the first formula for R. This is the one that we're going to look at now. All right, so R, all right, where's my pen? All right, I'm not seeing my pen. All right, why am I not seeing my pen? All right, oh boy. All right, I just ran into some issue right there, so my PowerPoint froze. So that is why I was unable to see the pen. So since the PowerPoint froze, I'm going to open a blank document. All right, for some reason, since today started, the computer is moving really slow. So my apologies. Let me see. I'm going to open it with Zoto here. All right, so let's wait until it finishes load. All right, so writing now our new correlation formula for R. R is now going to be given by, it is n times the sum of x times y minus the sum of x times the sum of y divided by the square root of the entire square root now. So let me put a big square root, the square root of n times the sum of x squared minus, in bracket, the sum of x all being squared, put a bracket around this. They will multiply it by n times, in bracket, the sum of y squared minus, well, I didn't need to put a bracket here, minus the sum of y all square, close this bracket. All right, so let me extend the square root now. This is the formula. Now, Jamie, you don't have to remember it because, again, I say it's on the formula sheet, but I would prefer if you remember it because it makes your life, you know, a little bit easier when you remember it and it saves time. So every minute I know persons, they're going to be skipping back and forth on the page, but if you remember it, then it's easy. And then there's another formula that you're going to need to know, which is finding the equation of the line. We need to know the gradient. Now, the gradient is then going to be found by this formula. This is the formula we're going to use. So B is equal to, it's almost the same as the formula for R. It's the sum, n times the sum of x times y minus the sum of x times the sum of y divided by, then, now look at this now, Jamie, because B and R have a very similar formula. It's then just n times the sum of x squared minus the sum of x all square. And that's how we're going to find the gradient B. All right?
All right.
All right, nice. Then there's one more formula. Yes and no, it's a lot of formula, Jamie. There's one more. We're finding the y-intercept now. So the y-intercept A, we're going to find it by this formula. It is the sum of y minus b times the sum of x divided by n. This is to find the y-intercept. It's the sum of y minus b times the sum of x divided by n. That's for the y-intercept A. And then, of course, we can write it in the form y equal to a plus bx. All right? So that's the formula that we're going to use to find A. Cool?
So,
All right, so we're just going to do one quick example now. The same question we did yesterday. And of course, Jamie, again, I'm going to send this document right here, so don't worry. We're going to do the same question right here. And then you're going to do the second one now that had no correlation. And then I'm going to let you do the 2016, 2017, and 2018 past paper with correlation. All right, so let's do back this first one here, and you're going to see the slight difference. All right, it's going to be very close, but let's look at the slight difference. So this question right here, can you take back another screenshot for me so we can write down X and Y? You got it?
so
All right, you got it down? So help me with those values now. X was what now?
hold on, this loading still.
Oh, 50, 50.1 then,
48.3,
48.3,
45.2,
45.2,
44.7,
44.7,
44.5,
44.5,
42.7,
42.7,
39.5,
39.5,
38.0.
38.0. Thank you. All right, let's go. Y quickly.
178.5,
178.5,
173.6,
173.6.
164.8,
Yeah,
163.7,
163.7.
168.3,
Yeah,
165.0, 155.4, 155.8.
All right, great. 155.8, right?
Yes, sir.
All right, thank you. All right, now that we have X and Y, now we need, just gonna write down what's the sum below it. So the sum will pop out our calculator. The sum would be, we'll add that up, 50.1 plus 48.3 plus 45.2 plus 44.7 plus 44.5 plus 42.7 plus 39.5 plus 38. I get 353. Did you get 353?
Calculator was
All right. All right. In the meantime, let me add the next part now. 178, 163.7, 168.3 plus 155.4 plus 155.8. This one I get, the sum is 1160.1. All right. No, I think this is definitely wrong. I doubt this 8 would add up to be so low. 178.5, 173.6 plus 164.8 plus 163.7 plus 168.3 plus 165.0 plus 155.4, 155.8. Yep, I knew something was off. This was 1,003 something. Yeah, because this looked too small to get this sort of a result.
Yeah, 1325.1.
1325.1. Thank you. Now that we have the sum of X and the sum of Y, in this case, we know that we're going to need the sum of X squared and the sum of Y squared, and we're going to need also the sum of X times Y. So we're going to write down our table first of X times Y, and we're going to multiply them. All right, so let's multiply them. We'll multiply X times Y, 50.1 times 178.5. That's a big number, 8494. Is it 84 or 8? What you getting?
Like 8942.
All right, such a huge number, 8942. All right, keeping it to one decimal place, I put 0.9. 48.3 times 173.6. I get 8384.9. Then 45.2 times 164.8. We get 7448.96. 96, I'll just write that one exact. 44.7 times 163.7. We get 7317.4. 44.5 times 168.3. That's 7489.35. 42.7 times 165. We're getting 7045.5. Then 39.5 times 155.4. We get 6138.3. And then we get 38.0. 38.0 times 155.8. We get 5920.4. We're going to add all those now. 8942.9 plus 8384.9 plus 7448.96 plus 7317.4 plus 7489.35 plus 7045.5 plus 6138.3 plus 5920.4. Adding all that, we get the sum is 687.7. Ooh, nice. Now we need two more tables. We need x squared and we need y squared, then we're done. All right,
X square. Wait. Oh, yeah.
Yeah, we're gonna need x squared and y squared. Yeah, it's a lot. But of course, in the exam, I'm gonna show you, they're not gonna let you do all of these rigorous computation. They're gonna give you what is the sum of x squared, and they're gonna give you what is the sum of y squared. The only one you'll need to find is this one, x times y. All right, so you won't have so much calculations to it. All right, but if in case one, as we said, integrated has only been around for 5 years, maybe 1 year they decide, maybe this year they decide to actually give a longer working out question, then of course you'd have to do everything, but they haven't done so as yet. Now finding x squared, 50.1, I will square it, 2510.01, 48.3, I will square it, we get 2332.89, 45.2, I will square it, we'll get 2043.04, then 44.7, I will square it, we get 1998.09, 44.5, I will square it, we'll get 1980.25, 42.7, I will square it, we'll get 1823.29, 39.5, I will square it, we get 1560.25, and 38 square, we get 1444. Now adding them up, 2510.01 plus 2332.89 plus 2043.04 plus 199.8.09 plus 1980.25 plus 1823.29 plus 1560.25 plus 1444, we get 15,691.8. Almost finished. Y squared time now. My gosh, these numbers are huge. 178.5, I will square it, we get 3186.2.25. 173.6, I will square it, we get 30136.96. All right. And then 164.8, I will square it, we get 27159.04. 163.7, I will square it, we get 26797.69. Then 168.3, I will square it, we get 28324.89. And we get 165.0, I will square it, we get 27225. 155.4, I will square it, that's 24149.16. And 155.8, I will square it, we're going to get 24273.64. Now, in that case, now we can add them up. 31862.25 plus 30136.96 plus 27159.04 plus 26797.69 plus 28324.89 plus 27225 plus 24149.16 plus 24273.64. Adding that up, we get the sum is 219,928.6. Ooh, now we can do our calculation. So now we can write down our formula and we can tell them now, of course, we know R is equal to n times the sum of xy minus the sum of x times the sum of y over the square root of n times the sum of x squared minus the sum of x all squared. Put a bracket around this. Put another bracket now. N times the sum of y squared minus the sum of y all squared. All right, so let's go ahead now and perform our computation. So R is gonna work out to be equal to N. N is, remember, it's how many variables we were given, data points, 1, 2, 3, 4, 5, 6, 7, 8. So in this case, N is 8. So it's 8 times the sum of XY right here, 8 times 58,687.7 minus the sum of X, 353, times the sum of Y, 1325.1, divided by the square root of N. N is, of course, 8 times the sum of X squared. The sum of X squared was 15,691.8. 8 times that minus the sum of X all squared. The sum of X, 353 all square. All right, and we close the bracket, and then we multiply it by 8 times the sum of y squared. The sum of y squared was 219,928.6. And we subtract the sum of y all square, which is 1325.1 all square. Close that bracket. Whole heap of calculation. So let's simplify the numerator part first. Simplifying the numerator, this is going to give us R is equal to, so putting in the numerator in our calculator, 8 times 5868.7 minus 353 times 1325.1. When you're putting this in a calculator, Jamie, I want you to make sure that you put a bracket round 353 and a bracket round 1325.1. All right, pretty much bracket everything. So 8 bracket 5867.7 bracket minus open bracket 353 close bracket open bracket 1325.1 close bracket. Just bracket everything. When I bracket everything and put it in the calculator for the numerator, I get 1741.3. That's what you got?
Yes, sir.
Good. Then now we have the square root of, now we're going to work out this part separate, all right? Work out this part now separate. That part, 8 times 1569.1.8 minus 353 square. Working that out, I get 925.4. Do you get that?
Yes, sir.
Nice. Then we're multiplying it by the next part, 8 times 219,928.6. Close the bracket, minus, open the bracket, 1325.1 all square. And I get 3,538.79. So R is just working out to be 1741.3 over the square root of, we can multiply those now, 925.4. We're getting a big number, 32,74796.3. They will square root it. I will get 1,800 and something. So it work out nice now, 1809.6. Now we can do our division. 1741.3 divided by the answer, we get 0.96. Now, Jamie, remember yesterday we got 0.97 the other way, remember?
Yes, sir.
Notice that we almost get the exact same thing. So I'm telling you, this method and the other method is the same thing, but different formula. Now tell me, why would they make two formulas, Jamie? First and foremost, why do you think they'd make two formulas for the same thing? Why would we want to use this one instead of the other one?
Because the other one is more steps. You have to find the mean and square it. And
I
well,
mean, nothing is wrong with finding the mean. What's wrong with finding the mean and doing it that way? That's fine. But why do you think there would be a need to use this formula instead of the next one?
let me see.
All
This
right.
one considers the amount of values.
Ah, very good. That too, that too. Sometimes you can be, there are two benefits. Sometimes it can be given a large number of data sets, maybe like 50, n is 50. Are you telling me you work out x minus bar x for 50 elements? No, that's crazy, right?
Yes, sir.
So even though that would give you the true value for R and the true value for the next one, then it's easier to just sum all of this because we can put in these data in our spreadsheet and let the computer work out the sum, work out the sum of x squared. Computer can do that easy. So this one is time free, it's less time consuming. So this formula is less time consuming. Now the next benefit, which I absolutely want you to remember, is sometimes the data points, there is no correlation. When there's no correlation with the other one, generally you're going to get the R value to be 0 because in theory, that's what it should be. But when there's no correlation, because we want to be able to predict, we want to be able to write down the equation that can predict any data points, even though there's no correlation, we still want to get R to be a number. So we can get B to be a number. So we can get the equation of a line. So we can still do some prediction, even though there's no correlation. Does that make sense?
Yes, sir.
So this one is more practical. All right. So this is a more practical use of the formula. Whereas the other one now is more rigorous in terms of the definition of what correlation is and finding the mean square value. That one is a more defined version of it, whereas this is more for practical purpose. So now let's go ahead and find our B. Our B, we said, B, remember, was n times the sum of xy minus the sum of x times the sum of y, but then it's just divided by no more square root now. No square root when you're working out B. It is just n times the sum of x squared minus the sum of x all squared. We pretty much wrote these down already. The numerator was from around here, the same numerator, 1741.3 divided by, now we had worked out that part in this bracket here. And this bracket had worked out to be 925.4. So in this case, it's just 925.4. So we do that, 1741.3, or divide it by 925.4, and we get 1.88 for B. We get 1.88 for B, Jamie, and that's nice. After we find B, you're going to need to find your y-intercept A. But the y-intercept A will say is the sum of y minus b times the sum of x, all divided by n. The sum of y, we said the sum of y was 1325.1, 1325.1 minus b, which is 1.88 times x, sum of x, and the sum of x we said was 353. And then we divide it by n, and n was 8. We'll put that in our calculator, 1325.1 minus 1.88 times 353 divided by 8, I will get 82.68. In other words, Jamie, we can write down that the equation then is therefore y is y hat, always leave off my hat, y hat is a, which is 82.68 plus the gradient, which is 1.88 x. Now let us check and see if that was what we got yesterday. That's why I made sure not to close it. Now, Jamie, look at that, 82.8. And what we get today, 82.7. Same thing, don't it?
Yes, sir.
Basically, the gradient slightly different, 1.88, and this one was 1.91. Now, remember I said the other one, the first way we did yesterday, that gives you the true value. This is really a rough estimate. So we call them point estimates, and 1.88 is a rough estimate of it. So these formulas is just for more practicality of it. And in this case, now we can sub in when x is equal to, what was it again? 58. Let's see what y gives us. When x is 58, we get y is, so 82.68 plus 1.88 times 58, that will give us 191.7. Now, Jamie, this is a key thing. I didn't stress this yesterday, but I want to stress it today. Anytime you finish a question, it says, don't just write y equal. Always tell back what y represents. How tall would that person be? In other words, what we tell them is, when the femur length is 58 centimeter, the person a height can be expected to be 191.7 centimeters. All right, please write out a statement. All right, Jamie? When you finish, write a statement. All right?
Yes, sir.
Yeah. Cool. So you have to write a statement, and by writing a statement, then they can say, oh, all right, he knew what he was doing. He find the predicted value. Good. Because they're going to ask you to write a statement. So now that we get that out of the way, the second one, which had no correlation, now you're able to find prediction now using this formula. So now I'm going to ask you, Jamie, you can now open back this document. Remember, it's linear regression worksheet 1, and you can now do question 2. After you do question 2, you're going to do the exam questions now, 2015, 2016, 2018. Yes, so number 2 is all yours. Good. X squared. Yeah. At the bottom, we'll put the sum. Oh, Jamie, also, by the way, what time do you get home on Thursday?
Thursday.
On Thursday, yeah.
2 or 3. It depends how long I'm on the road.
Oh, I don't know if it would be possible that maybe for next week we could have a session a little bit later because Miss Southburn would like for you to, I think, attend a Zoom meeting next week at 6. So I don't know if we could maybe start 7 and finish 8:30. Would that be okay with you?
That's fine.
Yeah, it's just for next week because yeah, wanted to attend a meeting. All right, all extras are good. All of those are good. Good. All right, very good, Jamie. Very good. You remember the formula perfectly. Nice.
That's a really big number.
Yeah, you're gonna get a huge number. That's why I said I want you to like separate it before you don't put the entire thing in the calculator. Usually, like if you show the 38,000 whatever squared 8 minus that 554 square, work out that part of the bracket first. It
Yeah,
gonna be huge. Yeah, it gonna be huge. Yeah, I know.
I worked out that part and it's still really big.
Was really huge.
Yeah,
Oh, yeah, I get what you're saying. It's huge. It's huge. It's huge. But when we square root it, don't worry, it's gonna come back to a normal number, so that's fine. Yeah, I see it. It's huge. Yep, you're going to see the practicality of this formula though. Even though we know there's no correlation, that's why this one is a little better in terms of practical usage. Very good, very good. You see the practicality of it. We know there is no correlation from yesterday, but at least by getting a very, 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 very small number for R, this will allow us to at least be able to make a prediction, right?
So
Yes, sir. So that's that's why we do this one, Jamie. We like to still be able to predict, even though it's a very when R is that small, what do we say? There is what type of correlation? No correlation. Nice. No correlation. What if R was 0.8? What kind of correlation?
0.8.
Yeah, 0.8.
That's medium. What was the name of medium correlation, I think?
Very good. Moderate. Because R squared needs to be greater than 0.7. But if you square root 0.7, you get 0.84. So when it's greater than 0.84, which is 0.85 to 1, that's when it's strong positive core. Very good, Jamie. Very good. I see you remembering. Nice. What if it was what if R was 0.4? What type of correlation would that be? If R was 0.4,
Would be weakly correlated.
if R was 0.4,
R is 0.4. Hold on. Isn't there anything below
yeah,
0.3?
yeah, you're correct. Yeah, you're correct. You're correct. Yeah,
Yeah.
0.4. Yeah. All right. Nice. All right. What if R was 0.2?
Would be even weaker.
Weak. Yeah, weak correlation. Very good. All right, now finish this question now. Go ahead and find B now, and then write down the equation. And after you write down the equation, then you need to find the predicted value that they're asking for. Plus. Yep, so you notice, look at that, 52.5. So it really never helpful. So good, write out the statement. Yeah, write out the statement. All right, so in other words, we're saying there's no correlation between the temperature and number of soft drinks bought. No correlation. Nice, Jamie, nice. So my question to you is, which method do you prefer in terms of, as you were working it out, which one you think would be shorter?
I'm not sure, honestly. They're both really long.
Both of them really long. Yeah, I'd say the first method shorter. If it is like a little bit of data, if it's like 6 or 4. But if it's like 7, then maybe this way shorter. Uh yeah, because we'd have to find standard deviation, and that kind of take a while as well. So I'd say the first way shorter if it's less than 6. All right. So now you're gonna do some past paper questions on this now. So, all right, I'm just gonna read the question to you. All right. See, it's not. All right, my PowerPoint still froze with the question. So let me read out the first one that you're gonna do, which is the specimen question. All right, so this question now, Jamie, I'm gonna copy it. Let me see if I can copy it. I want to see how it will come out in the chat. Yeah, it didn't come out too bad. It came out perfect, actually. So that's a specimen question. It says company XYZ investigated the possible relation between blah, blah, blah. So this is an actual exam question now. Nice statement. Good. Very good, Jamie. Very good. I love the statement. Nice. And just like that, you get 3 marks just for that. All right. All right. Let me see if you didn't include anything. Estimate the number of minutes. Number of minutes. The worker is late for work 11 minutes. 11 minutes in any given month. You said 11 times, 11 minutes. Yeah. Yeah, that's good now. All right, now let's do the second part now. Copy in the second part. So the question says, comment. This is 2 marks now. Comment on the accuracy of your answer, given that another statistic, the correlation coefficient, R, was found to be 0.25. All right, so Jamie, I don't want you to say having a poor correlation. I want you to use the keywords that they highlight in the syllabus. Weak, moderate, or strong. Don't use poor. Weak correlation, very good. So you can say yes, so it's very inaccurate. We can deem it inaccurate because of weak correlation. All right, if you use the word poor, we don't know what poor means. But we know what weak is defined to be, moderate, very good. All right, how did you find this specimen question? Easy, right?
Yeah, it's simple.
Simple, yeah. It's very simple in the exam. So let me open up now the 2016. We're doing all of them by the different years coming up. So 2016, it's just taking a while. And you have multiple questions to practice as well in order to do the rigorous calculation. As I said, they haven't asked any rigorous question as yet, so you're fine.
Oh, sorry, I need to use the button.
All right, no problem.
Okay.
All right. So let me copy it now. Da, 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 da. So it says blah, blah, blah about tone. All right, I don't know how to print out this value. So I'm gonna ask you to create a table for me. Create a table and take down these values. So it has two variables, time in minutes and level of water. All right, so the times in minutes are 3, 6, 10, 18, 20, 28, and 35. All right, and then the level of water from the start is 0.5, 4, 6, 8, 10, 10, 12. All right, so the question part I says, let me just copy part I now. Part 1 says, draw a scatter plot to represent that, then briefly comment on it. Yeah, so I want you to just give me like a sketch right here. You can try to maybe scale it a little accurately so you can get a good idea.
Yeah, I was determining which one would be on the X, but I
Okay,
think
okay,
it's time.
okay.
Would it be time on the X?
All right, read what the question says. Which one would you be likely trying to predict? Always remember the one that you're predicting will be a Y. So maybe 1 hour later, we'd
Yeah,
want to predict level of the water, right?
that's
Yeah,
right.
so you're right. So time in minutes is X. So that's the key, Jamie. Always remember which one you're trying to predict is your Y. Hence, we use Y hat. All right, so when you do a scatter plot, I want you to always just put on a line of best fit. Before you comment, you can at least show them the best fit line, because it's really the best fit line you're gonna help to make a brief comment on the shape. All right, good. That's your best fit line. All right, now you're missing a keyword, Jamie, which is strong positively correlated. All right. Yes, strong positively correlated. Very good. If you look at the shape of it, how do I know strong? If you were to find the gradient of that line, positive, and based off how it is shaped, all right, notice that it have a steep gradient. A steep gradient means that R is always going to be closer to 1. And when R is closer to 1, strong correlation, strong positive correlation. So very good that you put in the positive correlation. That would have already given you 1 mark. But just to be completely accurate, you want to say strong positive correlated. So very good. How did you find this paper now?
That was the entire question.
Yeah, that was it. That's all that
Oh,
came on Scatterplot.
okay.
Yeah.
Yes, good.
Easy. All right, good. Let's step it up a notch now. 2017 was a little more challenging. As I say, it's mainly the probability questions that they make a little more challenging. Probability. They usually make scatterplot easy because they know that you won't have time in an exam to do rigorous calculation. But here's the next one. This is 2017. And this is part B. Why you put one there? 24 was good.
Sure, but it said during.
So the linear regression Y, where Y was treated as weight loss and X is the number of weeks. So during the 24th week.
Yeah, but wouldn't that just be 1 week since it's during that week?
Yeah, during that week. So you put 24. 24 was correct. Yeah.
Wouldn't 24 find the weight loss up until week 24? This one is worded weird.
Yeah, but that's fine. You're just gonna plug in the X as 24. Yeah. $15.55. Very good. And we don't know if it's pounds or kilos or we don't know. Oh yeah, it's kilogram. They told us it was kilogram at the top. So in 24 weeks, somebody would lose 15.55. That's a lot of weight. That's
Yeah,
that's
a lot.
yeah, that's a lot. Aha, here's the hardest one, 2018. So 2021 was easy as well. Very good. Strong positive correlation. Very good, Jamie. So that would give you your 5 and your 2 marks. Good. Excellent.
Hey,
All
five.
right. Yeah, the first part was worth 3 and the next part was worth 2. Yeah. All right. Now I'm just going to share screen. I'm going to ask you to screenshot this one. This is 2018 because I'm unable to copy it. 2018 because this one, somebody took the picture, so I can't copy the text from it.
Okay.
You took the picture?
Yeah.
All right, great. And this one was worth 4 marks. You can do that now. It says, show that B value worked out to be 0.962. Go ahead and show now that. Very good, Jamie. I see you remember the formula. Yes, n times. So you see why it's important to remember this one, right? Because tell the truth, would you want to be using the other formula?
There's another formula for B.
Well, no, but remember with the other formula to find R and then find
Oh,
B.
yeah, no.
Yeah. Yeah. So it's best if you remember this one straight off the bat because the other one is crazy to find R and then standard deviation of X and Y.
Oh, we already have all these.
Yeah, exactly. That's why they give us these, so you can just use those values. Three three two seven square minus 165 square. What was the answer supposed to be? 0.981. Something was off there.
I don't think I should have squared the sum of x squared. I did that by accident.
Oh, you put a square on it. Oh, that's it. Oh, I get what you said now. Okay. All right. I was wondering what happened there. You squared it. Yeah. I think that was 5815 in the numerator.
Yeah.
All right, great. You see that it's not bad, right? It's not bad.
So they put this to distract, I think.
Yeah, they put that, that's a what? That's a distractor, right?
So,
Because they know some persons are probably going to use the R formula to do that. Use that somehow, which really you didn't even need it. All right, so now I'm going to share screen again because I want you to do the second part. Me share. Da, 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 da. Oh, sorry, wrong one. All right, here's the second part now. Determine the equation for the estimated linear. Let's take a picture of this part and also take a picture of the third part. So notice 2018 had a lot of regression. So Jamie, we don't know how the regression question is going to come. That's why I just want you to know everything. Notice every year so far is a different thing come about regression, right?
so
Yeah, so we never know. Maybe this year is the year where instead of they give us so much calculating to do, maybe this year they just ask, they give you the data, sample data, then they ask you to maybe you have to do all the rigorous calculation for 10 mark. Maybe they decide to do that this year. I don't know. But we just want to make sure we know to do everything. Doesn't matter what they ask.
mushrooms.
Yeah. You took the two pictures?
Yes, sir.
All right, you can share your screen and take them on now. Beautiful, Jamie. Glad you remember that this is the formula you're gonna use. Nice. Sum of x. Very good. All right, good. So that's A. That's good. So write down the equation now. Now determine how much a person will get on the second paper if they got 20 on the first paper. Yeah, don't change it from 0.22. Yeah. It wouldn't affect it by much, but yeah. Very good, Jamie. Very good. All right, so basically, it don't even matter because if you get 20, 22, you're gonna get basically the same thing out of 30. That's roughly like 70% on both of the papers. Right?
Yes, sir.
All right, so how you feeling regard to now scatter plots and linear regression? It's easy, right?
Yeah, it makes sense.
Easy, and it's just a whole heap of
It's
extended calculations. Yeah. All right, good. So we only have two aspects to cover really in statistics now. Well, three. We started probability. We're going to look at the remainder of the laws of probability. We're going to then look at binomial distribution. No, binomial, me pronounce the word correctly, binomial distribution. Then we're going to also have to look at normal distribution. And then we'll finish statistics. For module one, we still have the little bit of trick to do. Once you finish that little bit of trick next week, then you're going to be doing a module one test. See, I almost out the way for, you should be finishing up all your IEs for next week, right? IE should be due like next week or week after next week, right?
whatever due the start of March, so yeah.
Start of March. All right. So the week after the start of March, then I can give you a module one test. And then by then we should finish statistics. Then I can give you a module two test. Right?
All right.
Yeah. All right. So I'm gonna send you a message regarding to how you can get the line of best fit on your graph in Excel. So I'm gonna, of course, ask my colleagues tomorrow at work how we can do that. All right.
All right.
All right. So take care, Jamie, and enjoy the rest of your evening.
All right, you too, sir.
All right.